All right, we are live. Welcome everyone to today's webinar on CycloneDX. We're just going to give all attendees a few seconds to make their way in. So thanks for your patience. But we will get started in about 90 or so seconds. So thanks for hanging with us. Hope you're doing well wherever you are. I know some parts of the country are quite cold right now, so I hope everyone is doing okay. That would be in the United States. But yeah, welcome in on this Wednesday, and thanks for your patience. Thanks for your patience as we just give attendees a few more seconds to make their way in. If you're just joining us, thanks so much for being here for today's webinar on CycloneDX. We're just going to give it another 45 or so seconds for attendees to make their way in to today's presentation. So thanks for your patience, and then we will get started momentarily. Just a few more seconds here. And again, appreciate your patience, and then we will get started. All right. Well, I think that should be enough time and we can get started. So, first, just wanted to thank you all for being here for today's webinar on the CycloneDX standard featuring Steve Springett, who's the chair of the CycloneDX Core Working Group. We're really excited that he's here with us today. My name is Andy Drukarev. I'm on the team at FOSSA. I'll be your host for today's discussion. Also thrilled to be joined by one of my colleagues at FOSSA, Cortez Frazier Jr., a senior product manager who will conduct a brief demo of our CycloneDX support toward the end of this webinar. Now, before I go over our agenda and introduce Steve, I'd like to cover a few housekeeping points. First, we will try to answer any audience questions or as they are submitted, if they are related to the topic that's being discussed on in that part of the presentation. If we can't get to them, we will also have dedicated time at the end for a Q&A. Either way, we do encourage you to submit any questions you have in the questions section of your BrightTalk console. Next, this webinar is being recorded and it will be sent out to you after the event. And finally, we at FOSSA will be following up after the webinar with a few additional resources and to see if there's anything we can do to help your organization generate and manage SBOMs. Now, let's look at our agenda. As you can see, we'll start with a very brief review of the modern SBOM landscape before introducing the CycloneDX standard. Steve will highlight some of the important parts of CycloneDX, its history, use cases, technical specifications, and then strategies for actually generating and importing CycloneDX. And then, like I mentioned, we will close with Cortez providing a brief demo of how FOSSA supports the standard. Now, before I hand things off to Steve, a quick word for folks who aren't familiar with FOSSA. We provide technology that makes it easier and more efficient for organizations to manage the open source software they use. That includes identifying and remediating open source vulnerabilities, as well as identifying and complying with licenses in open source code. And additionally, because the foundation of FOSSA is really our ability to quickly identify and inventory the components in your software, we offer a comprehensive SBOM solution. You can use FOSSA to import SBOMs from third parties and generate SBOMs in a range of formats, including, of course, CycloneDX. With that, so excited to introduce our speaker for today's event, Steve Springett. Like I mentioned, Steve is the chair of the CycloneDX Core Working Group, and we're thrilled that he's here today to discuss a number of key topics related to CycloneDX. Also, as you see, avid Formula One fan, and so excited to get his take on the goings on there. And with that, Steve, we'll hand things over to you to share a bit more about your background and some of your current focus areas.
Thanks, Andy. Thanks for the introduction, and thanks for the invite. Glad to be here with the FOSSA team. So yeah, I am the chair of the CycloneDX Core Working Group. Among other things, I also lead the dependency track project, the OWASP software component verification standard, which is a way for organizations to measure and improve their software supply chain assurance. And I do a bunch of other things regarding supply chain and security in the OWASP community. What I actually get paid to do is leading some security architects at ServiceNow. Um, I am an app. I am an avid Formula One fan, for sure. There's no shortage of drama behind the scenes, and I also like to collect mechanical watches. It's kind of a geeky thing of mine, I guess. I just get really fascinated about how something mechanical that was, designed 100 years ago could tell pseudo accurate time. It's quite a feat of mine, engineering. So anyway, enough about me. On to CycloneDX. Um, CycloneDX was a bill of materials format that was started back in 2017. And this happened a little bit before a lot of the NTIA efforts, National Telecommunications and Information Administration, started to realize that there was a market failure around bill of materials. People weren't asking for them, so people weren't producing them. That's kind of the definition of a market failure. But through all of that NTIA work, that eventually led to this executive order, which I'm sure many of us have heard about, Executive Order 14028, that essentially requires SBOMs for all federal purchases and renewals. Um, Still a lot of ongoing effort in terms of, or uncertainties, I guess, about what the enforcements look like and what the uh, what the exact timings will be in terms of this. But needless to say, SBOM is here. It is happening, and it does have a pretty substantial downstream impact on the entirety of the software ecosystem, simply because the budget of the US government is so large that it will have a downstream impact to a lot of organizations. So if you haven't heard about SBOM, or if you have, certainly be prepared to start delivering those this year, when the federal government eventually asks for them. So what is CycloneDX? Well, it's really a modern standard for the software supply chain. What does that mean? Well, it does a lot of different things. Now, a lot of the NTIA work and now CISA work has framed it into an SBOM format. Not exactly true. It's one of many capabilities of the format. So certainly software is something that CycloneDX can represent, but it can also represent services. Um, there's a concept called SaaSBOM, which is an inventory of all of your services, which is really important on the consumption side. Hardware bill of materials, because IoT, I heard it's a thing. And being able to describe what that hardware stack is, being able to describe what that software stack is that's running on that hardware, independent of one another, is kind of important for lots of use cases. Operational bill of materials, you can describe, what software inventory is affecting uh, your stack in operations. So that's a very common use case. And then, of course, all software has vulnerabilities, right? So you can describe these vulnerabilities either through an assertion process, which is vulnerability disclosure reports, or you can describe them with what we call VEX, or vulnerability exploitability exchange, which is mostly framed as a anti-advisory, being able to tell people that I am not affected by such vulnerability. So it does a lot of different things, and certainly SBOM is a core tenet of what CycloneDX does, but it also does all of these other things, um, and you don't have to use the SBOM support at all. Um, so Cyclone is actually very widely used today. Now, these statistics are from about a year ago. So the actual statistics, we'd have to go back and run the estimation numbers again. But I don't know if it would be 150, 200,000, something like that. But there's a lot of organizations using CycloneDX today, which is great. The interesting thing about this number, however, is that it's large enough to indicate that this really, really works, but yet it's small enough in the context of the sheer number of organizations that exist. One of the things that the executive order has certainly done is really popularized into almost the mainstream SBOM in our vernacular. So we expect these numbers to dramatically increase throughout this year. Just some other data on usage statistics. Now, this is usage statistics just from one tool. Obviously, there's literally hundreds of tools that support CycloneDX today. I think we're up to 170-ish tools. This is statistics from one tool, where CycloneDX, there's 300 million components represented in CycloneDX every single month. So the usage is certainly extraordinary. Whether or not we're trading these SBOMs, that's kind of a different story. But they are certainly being produced. There's a lot of use cases that CycloneDX supports. As an OWASP project, we basically came from a security context, which is a little bit different than some of the other formats and kind of their origin stories. But our origin story was really about security. We think security is a primary concern. It's obviously a board level room discussion pretty much all the time, and that's kind of the expertise that we bring to the format. But in order to do that, you have to first be able to describe a complete and accurate inventory. Without that inventory, all other forms of analysis become moot. They're not important. So it's really important that you understand that you form that basis of that inventory initially, and then once you have that inventory, yes, you can perform different types of vulnerability analysis on it. For example, you can do known vulnerabilities with like FOSSA or the NVD or some other vendor. You can do also unknown vulnerabilities because CycloneDX supports services. So there's a lot of different types of vulnerability analysis that you can perform. Many different ways to perform integrity verification, both on the bomb itself, which can be independently signed. So we support obviously external signatures, but we support internal signatures as well, envelope signatures. So you can verify those. You can verify the integrity of the packages themselves with support for hashes and all kinds of other mechanisms. Um, One of the things, especially for open source, is the number of open source packages that exist, right? Open source is, software. If software is eating the world, open source is eating software. And a lot of that software is in the form of packages, most of them managed by package managers. And with CycloneDX, you can evaluate those packages because you have enough data to tell you enough information about that package so that you can evaluate it properly. Um, License identification and compliance is certainly one of the use cases that we support. We didn't know a lot about the licensing space when we entered the first versions of CycloneDX, which actually did support SPDX license IDs in version 1. But then we quickly realized that there's a whole world of licensing outside of SPDX license IDs. So we support license expressions and commercial licenses and some other stuff as well. So you can certainly use it for license identification and compliance. Um, Software is complex, and sometimes components include other things. We call these things assemblies. I like to kind of equate it to like a dashboard of an automobile, where you might have a dashboard, and within the dashboard, you might have an instrument cluster. And within that instrument cluster, you might have a tachometer and a speedometer. And within those, you might have some LEDs and some plexiglass and some capacitors and these types of components. Well, complex software is can be kind of like that as well. And with CycloneDX, you can represent these really complex component assemblies and independently digitally assign each one of those component assemblies. So if you've got parts of these assemblies from different suppliers, each supplier can independently sign their specific portion, which is a really interesting use case. Um, Open source is really the ultimate supply chain, and components are renamed, modified, reused, distributed like all the time. And being able to capture that pedigree, all of those relationships in terms of descendants, variants, and ancestors, and what specific modifications that you've made to open source components. Maybe you've backported security fixes. Maybe you've added some enhancements for whatever the case is. Well, being able to describe all of this data is something that CycloneDX has supported for many years. So we call this pedigree, which is kind of the DNA of component modifications and identity. We also support component provenance, which is the concept of where you retrieve something from, whether it's from an open source package repository, from a commercial supplier, and that whole chain of custody there. So that's really important, like who you got something from. Is something that we also support. Well, services, software is certainly, eating the world. Software does not live in a bubble, and it hasn't for the last 2 decades, right? Modern software relies upon things on the internet or things within its environment that it's operating in. The fact that I'm using BrightTalk right now to communicate with you is fact that I'm relying upon external services to do what I need to do. Whether you are describing, services to get Google Map information or stock quotes, or trying to control nuclear launch codes, right? Your software relies upon a service to be able to do something. And services are a really important part of your software's inventory. And again, CycloneDX has supported this type of inventory for multiple years, including like the data classifications, the directional flow of data, who the providers are, all kinds of stuff about the services are captured. And finally, and certainly not least, dependency relationships, right? Components depending on other components, components depending on services, services depending on other services. So all of those complex relationships can be captured, as well as all kinds of other types of relationships as well.
Thanks, Steve. Just to jump in, because we do have a few questions. Uh, first, for security vulnerability analysis use case, how far does CycloneDX extend beyond simply stating related CVEs to benefit the vendor due diligence in acknowledging remediation status of vulnerabilities?
So for security vulnerability analysis, okay. So it goes, for the vendor due diligence portion, this is kind of talking about really VEX, or vulnerability exploitability exchange, is kind of my understanding of this framing of this question. Um, but VEX is a nice concept. It gets complex, but the world doesn't revolve around CVEs, unfortunately, right? That was kind of the intent, but we've seen the emergence of decentralized vulnerability intelligence, and today, most vulnerabilities that are publicly disclosed are not in the NVD, so therefore they do not have CVEs. So we actually capture, CycloneDX can capture all of these vulnerability aliases that exist. So being able to tie like maybe a vulnerability from one vendor to maybe a GitHub security advisory that's not public, for example, on the NVD. So vulnerability aliasing is a core tenet of the spec. In terms of like remediation status and that sort of thing, there is a lot of nuance in terms of, am I exploitable or not? The world isn't black and white, right? The world is a lot of different shades of gray. And you're going to have scenarios where, yeah, you might have like a vulnerability, a CVE, whatever, that has like a 10.0 rating, right? But in the context of your product, right, your product might not actually be, it might be exploitable, but not to that level of severity. And you can actually describe that with CycloneDX. So you can describe these different shades of gray, which I think is really important. Um,
Thanks. Yeah, thanks, Steve. I think the one other question related to this slide, I think was probably submitted before
mm,
you got to this section, but it was about software pedigree. What is software pedigree? To whoever asked this, if there are specific parts of software pedigree that you'd like Steve to dive deeper into, please feel free to let us know. But Steve, I think you gave us a pretty good overview of that after the question was submitted.
yep, yeah, I think so. But if there are further questions on pedigree, I'd be happy to answer them. Um,
Great.
am I a Max Verstappen fan? No, sorry. I root for number 44. That's my guy.
Yes,
Uh,
that was a question we were, uh, probably the most important question we'll get, during this webinar, but was Steve a Max Verstappen fan? But, on that, Steve, let's turn it over to you, and we can continue.
all right. Let's see. History of SPDX, or history of SPDX, history of CycloneDX. We in 2017, in the OWASP dependency track project, which was, it's a project that started in 2013 that really was its basis, at its core, was a bill of material type of use case. At the time, I had a need to track the inventory of server appliances that my employer was selling to the market. So I needed to track the hardware, I needed to track the firmware, the operating system, OS packages, application libraries. I mean, the entire stack. And that's kind of the use case that CycloneDX was kind of built around. So in 2017, we started looking for specs that could be able to reach, my requirements. And we looked around, we didn't really see anything. Yes, we evaluated SPDX, and they were doing some really amazing stuff with licensing, but their file format didn't really work for us. It didn't meet any of our use cases for the most part. So it was kind of unfortunate, but insert your XKCD comic strip here. A new format had to be created, and we launched that version one in 2018. And version one was pretty elementary. I mean, it did some really basic stuff, but it captured the essence of what it is that we're talking today, and especially with regard to the executive order, which was, what is my inventory? What is the identity of those inventories, like the CPEs or the package URLs or PURLs, and of course SPDX license IDs at the time. But that was kind of the essence. So we could have some really basic vulnerability management and license management use cases back then. But since then, the format has grown dramatically. We used to frame it as kind of a lightweight standard, and it used to be lightweight. It still kind of is, but we frame it today as more of a full-featured, it's a full stack specification. So every year we've kind of released an updated version of the spec up through the current release, which is 1.4, which we added vulnerability support with VDR and VEX and bill of vulnerabilities. All of those capabilities actually we were working on in 2019. So we added extensions in 2019 that allowed us to experiment with a lot of different things. And that's kind of one of our design philosophies are. We try to deliver value to the market as quickly as possible in a way that we can innovate in the future and build upon the work that we've done. But we also have multiple feedback loops within the CycloneDX community, including an industry working group, which is kind of our equivalent to like an on-site customer in the agile or extreme programming sense. But we have all kinds of different feedback loops, and one of the feedback loops that we had was about this vulnerability support, which was like 3 years in the making. So that was more the long tail type of feature. But this is kind of what we do. We release updated versions of the spec every single year. In fact, we're currently working on 1.5 now, and we're currently planning 1.6 as well. So I'll get to those in a little bit. Okay, so what is CycloneDX? If you look at like a bill of material, or if you look at the spec from like the top down, what does it do? Well, the very first part is just about the metadata itself, right? What is the bill of material? What is it describing? What software, what service is it describing? Um, who is the manufacturer? Who is the supplier of those services? What tools were used to create the bill of material? That sort of thing is really in the metadata section. Um, the components and services, that's really the heart of your inventory. So what are the hardware components? What are the software components? What is the inventory of those, including any, pedigree, like all the modifications thereof, all the assemblies, like a component, including other components. All that kind of metadata about that inventory is captured in components. Likewise, services is a equal, you know, inventory type within the bill of material format. Services are really important, but we capture the endpoint URIs, the data classifications, directional flow of data to and from different things, who the providers are, all kinds of information about the services. There's enough information on services so that you could actually create the basis of a threat model. That was really the intent on the services support. Um, and services really are important for things like mobile apps, which don't usually, run self-contained, right? They usually fetch things off the internet or, whatever. But yeah, it's really important feature of the bill of materials form. Of course, the dependency relationships, that's a section of the bill of material format that we can capture, what components rely on other components, or, what services depend on other services, and kind of mixing and matching those as well. We capture the entire dependency graph, so you can specify what the direct dependencies are, what the transitive dependencies are, that sort of thing. Compositions are really important, and this actually came about. Cyclone really came about in, it started before this NTIA effort, but this was one of the features where NTIA and their work really influenced, I think, some of the spec. Compositions is really the idea of being able to capture completeness, right? How complete is my inventory? How complete is my assembly, or subassembly of my inventory? How complete is my services? How complete is my relationships? And being able to describe, hey, this thing is 100% complete, or I'm only describing maybe the first party components, or maybe I'm only describing the third party component inventory, or maybe I really don't know what's in this thing, right? Maybe I got a library from a commercial vendor, and I honestly don't know what's in there. But being able to describe that is part of the spec. Of course, vulnerabilities are also part of the spec. Vulnerabilities can also be inventory. We support a bill of vulnerability use case, where if you want to trade vulnerability information between different systems, perfectly valid use case. Don't have to use it for an SBOM format or anything else. If you just want to trade vulnerability information between multiple systems, CycloneDX can do that. But we also obviously can support, hey, is this component vulnerable to this particular vulnerability? So those are use cases we support as well as the ability to say, no, we've actually backported a fix for that vulnerability and we're not actually affected. Um, CycloneDX is extensible. There's multiple ways that you can extend CycloneDX, and we encourage a lot of innovation in that place. Some of those innovations actually make it back to the core specification as well.
Thanks, Steve. We do have a few questions. Thank you to everyone who has submitted them. I think for this slide, there is one that asks, "How does Cyclone DX capture services? Can you give an example?"
Yeah, so a couple of different ways. You might have, for example, a library. Maybe it's a library, it's a convenience library used to fetch stock quotes. And that library might have a constructor and you pass it in a stock ticker. And well, that library doesn't actually do anything, right? You're just passing in a stock ticker. The library actually relies upon an external service to actually get that data back, and then it returns it, with your function call. So being able to describe that kind of reality is what CycloneDX can do. So you can describe your reliance on that Java stock ticker convenience library, and then you can also describe that that library has a dependency on that service. And you can describe that maybe in the case of a stock ticker, maybe you're passing public, in terms of data classification, you can describe the data classification as being public. But maybe on the return, you're actually getting PIFI or personally identifiable financial information in return. And you can describe that, right? So you can describe that, hey, I'm passing public information to this service, but I'm getting personally identifiable financial information in return. You can also describe, obviously who the providers are, what the endpoint URIs or URLs are. So there's a lot of really interesting data that you can capture. Services also have licenses, right? We think of licenses in terms of software, but there's also licenses applied to services, and that's also an important use case. So you can describe things like that, but you can also, if you wanted to use nothing but services, you can describe complete microservice architectures using CycloneDX, and we call that basically a SaaS bomb, or software as a service bill of material.
Thanks, Steve. I think we have time for one more question now, and then the remainder we will take at the end. And so this question, again, it's something you covered, but if there is any other detail that you think would be good to provide, please, feel free to do so. Can you elaborate a bit on what components are in the CycloneDX spec with regard to packages/dependencies, and also on the nesting of components?
Yeah, so we support package URL. We support which is basically a way to identify what a package is, as well as provide location information for that package. So in CycloneDX, package URL or Perl is a first-class citizen when it comes to component identification. So we don't treat it as some kind of external thing. It's part of that component's identity. So we support that, but we also support like the individual supplier, right? So if you have like a commercial piece of software as part of your inventory, well, you can specify individual suppliers for each one of these things. So you have a lot of different ways that you can specify different things about the package URLs or the package information. In terms of like component assemblies, this is a very common use case in the C worlds, I guess. Statically linked libraries. Well, you're basically embedding those dependencies or part of those dependencies in your binary. So that's kind of one use case. Another common use case, at least in the Java world, is the concept of Uber jars or fat jars, which is basically the concept of using a jar, which is a Java archive, and then including other jars within that jar. Spring Boot, for example, if you're developing microservices in Java, Spring Boot does this. So you'll end up with your jar, but then you'll have all of your other jars inside of it. So that's a very common scenario to describe these Uber jars or fat jars. Um, but in a lot of cases, right, we make modifications to things, and it's really important to kind of include those assemblies. And like I said earlier, if you're getting these assemblies from other suppliers, you can independently sign using envelope signatures. We support XML signature as well as JSON signature format for envelope signature signing. You can perform that on your component assemblies as well, which I think we're the only format that does that. So let me jump into to that next slide. And there's a lot of different ways that we can go about generating bills of materials, right? The first question I think we have to ask is, do we have source code? Because that's kind of going to have to kind of dictate what kind of tool we can use, right? On one side, if we don't have source code, well, that's unfortunate, and thankfully, there's a lot of both commercial as well as open source tools that you can use to do binary analysis that will generate a CycloneDX bill of material. If you have a working build environment and source code, well, fantastic, because you have a lot more options at your disposal. A few things that you have in terms of considerations is being able to integrate it natively into your build tools, right? If you've got a Java Maven plugin or a Go plugin or NPM plugin, right? You can just make it a native part of that build lifecycle, which I really, really like. I like the whole native aspect of it because if you have a Java or developer or a JavaScript developer or whatever, it's just a native part of their ecosystem. It's not this external tool that they have to deal with that just doesn't fit right. So that's certainly one way to do it. One of the benefits of doing that, especially for things like web-based front ends, is that your inventory, for example, in your package lock.json, um, it's not accurate. It's not going to be accurate. It's more of a recommendation. As you are building web-based front ends, your front end typically goes through like Webpack or some kind of bundling thing, and the actual inventory that you end up with is going to be very, very different than what your package lock.json actually states. So that's certainly one of the benefits of using like some of the native tool integration. But that comes at a cost, right? That accuracy actually does come at a cost. That cost is that you have to start integrating with all of your different individual builds, which can be time consuming, which is one thing that you can do is target the software factories themselves, right? You can target Circle CI or target GitHub Actions or Jenkins or whatever, and do so in a way where every single build that you do from these factories can automatically generate a bill of material. Will it be as accurate as the native? Probably not, but you're able to, in mass, do potentially thousands of builds with not a lot of effort, right? Because you're targeting at a much higher level. Um, so that's certainly something to consider. One thing that a lot of folks think about is that SBOM is just a one-time event, and it's really not. Think about SBOM as more of a process, right? You certainly there is a generation aspect to it, but are you actually complete? Because if you've modified some components, well, you might want to document that and enhance the bill of material, right? Augment and modify it and correct it to add some of this other data. For example, if I'm using a package manager, that package manager is not going to know that, yeah, I'm using this version of jQuery over here or whatever, Angular. It doesn't know that I've actually modified that version. It has no idea. You do. And you can actually, create that pedigree information once you've actually generated. So think of SBOM as more of as a process rather than a one-time event. We certainly want to generate SBOMs with every build, right? If you create that initial investment and just make it a natural artifact of building software, your life is going to be much, much simplified. Now, granted, not every ecosystem can do this, right? We still have C projects that still use, uh, guidance from dating back 40 years, right? They don't use package managers, even though package managers in C have been existing for the last decade. It's very uncommon to come across a project in C that actually uses them. But for the ones that do, I think creating an SBOM for every single build should be just a natural artifact of building software. We certainly want to save the SBOM alongside that artifact. So if we're pushing it to some kind of repository, whether it's an OCI a repository or a Maven repository or whatever the case is, store that SBOM right next to that artifact. That way they are, together. Um, and if you are distributing SBOMs, obviously make sure you have proper controls in place. Whether it's, if you're commercial software, make sure you have authentication and authorization, in place. Unless you're one of the very few vendors who just, have complete and utter transparency. And there are a few of those, but I think those are not the norm. Most of us, I think, from a commercial vendor space, we put our SBOMs behind some kind of customer support website or whatever it is. So make sure you have proper controls in place for protect the business. For importing bills of materials, accuracy kind of matters, right? Garbage in, garbage out. So the more accurate the bill of material is, regardless of format, right? Cyclone, SPDX, it doesn't really matter. Accuracy really matters though. So try to make sure that you're building the bills of materials in a way where you're actually going to get accurate information as a result. Completeness matters. The more data you have represented in the bill of material, the more useful they are, the more different use cases that you can use them for. For example, if I'm, having a bills of material that includes services, fantastic. But again, your package manager isn't going to know that, hey, I rely on this external service to fetch stock quotes, right? It's not going to know that. They're not that smart. But if you know in advance, there's really easy ways to kind of merge bills of materials together, at least with Cyclone anyway. It's fairly elementary, and there's multiple tools available to be able to do that. Conformance matters, right? Making sure you have a valid, that's something that valid according to the spec. With Cyclone, we wanted to make the specifications in a way where you could use any validator to validate the spec. So our specs are available in JSON schema, XML schema, and protobuf, and you do not need to use specific tools or apply any kind of business logic on top of the XML, JSON, or protobuf validation that happens out of the box. Now, we have validators available, like the CycloneDX CLI, which it does validation, it does merging, it's kind of a Swiss Army knife, if you will. But you can use any validating tool that you want as long as it supports XML or JSON or protobuf. Consuming Cyclone is kind of universal. It doesn't really matter like what the use case is. Like supporting a hardware bill of material is kind of the same thing as supporting a software bill of material from a CycloneDX perspective, right? They functional. They really are not different from one another. So from a consumption perspective, importing CycloneDX is kind of universal regardless of the use case.
Thanks, Steve. I think just if I could come in quickly here, for everyone who has asked questions that we haven't addressed, our apologies. We will do our best to get to them here in a few minutes once the remainder of the presentation is complete. We do have a few more slides and then a quick demo, and I think this slide in particular. Frankly, is one that we at FOSSA get a lot of questions about, and Steve, I would imagine you do as well. CycloneDX obviously being one of the more prominent human and machine readable formats, but there are a few others. And would love if you could sort of take this opportunity to talk through some of the major differences between CycloneDX and SPDX, as well as SWIT tags.
Yeah, yeah. This is certainly a question we get a lot of. I'm sure the SPDX folks get a lot of these questions as well. We all get questions. If you're not living and breathing in the space, there's a lot of questions out there, and that's great. But SPDX is a Linux Foundation project. It started well before Cyclone. Their main purpose initially was license and intellectual property use cases, and they do a phenomenal job at that. Cyclone supports all the SPDX license IDs and license expressions, but where we differ dramatically is on the file format. So SPDX is certainly, this is kind of the structure of an SPDX document. They have a version 2.3 version of this. It's not as colorful. The 2.2 one is more colorful than the 2.3 one is, which is why the 2.2 is still in here. But not a lot has changed in the 2.3 diagram anyway. But they capture package information, file information, snippet, which is something that Cyclone doesn't support yet, although our snippet support is going to be very, very, very different from what SPDX does, because we have entirely different use cases. Licensing, relationships, annotations is something SPDX came from a lot of manual use cases. You have a lot of legal type use cases for license and intellectual property, and annotations was one of these things where either a tool, a human, or an organization can annotate, make comments on specific parts of the SPDX document. Cyclone didn't really grow up in an age of manual use cases. We grew up in a world of automation, but that's actually something we're adding to the next version of the spec because we have a lot of interest in annotating commercial software, not necessarily open source. So compliant, entirely different use cases. But that's kind of the structure of SPDX. It's available in a lot of different formats. RDF, which I'm not going to get into. Excel spreadsheets, because again, they had a lot of manual use cases. Tag value, which is kind of their own format. Cyclone will never create our own format. That's not what we're going to do. JSON, which is great. XML, which is great. YAML, yeah, well, we're not going to support that either because there's not a lot of really good ways to identify what the end of file is. I mean, there is a part of YAML that allows you to identify what the end of file is, but nobody really uses it, which is unfortunate because it is optional. So we're not going to support YAML, but SPDX does. SWIT tags, now this was actually included in the NTIA efforts. SWIT is definitely not a bill of materials format. It was not designed to be one. Can it be misused to be one? Sure, it can be. But it's really, its benefit is really for software identification of commercial software for the purpose of entitlements, right? If you are a vendor, commercial vendor, and you want to manage your entitlements and create an identity for a particular piece of version of your software, SWIT is really the ISO way to do that. Cyclone, we recognize that, yeah, it is not a bill of material format, but it's actually really good at the identification of commercial software. So Cyclone actually natively supports SWID. So when you adopt Cyclone, you automatically gain SWID support as a result of that. So that's kind of the differences. I mean, we've come from the security space and kind of moved into other things. SPDX has come from a licensing IP space, and they've kind of moved into security. So that's kind of the landscape as is. I would encourage the audience, though, to actually go out to the websites of both specs, actually read them, read the specs, understand what's available to them, look at the available tooling for both of the specs, and evaluate, hey, which thing is going to be better in my organization or for my use cases. I would encourage everyone to do that. Don't take my word for it. We are actively working on Cyclone. We're currently in heads down doing 1.5 development work, and we've got a lot of contributors, especially PhDs in machine learning, that's helping us out for some ML support that we're introducing in 1.5. So ML transparency has definitely been gaining momentum over the last couple of years, especially in Europe. So ML transparency is coming to 1.5 in Q2. Formulation or a manufacturing bill of material. This is the concept of how something was built, whether it's software, whether it's an IoT toaster, or how my service was deployed. What is the formula for making that thing a thing, right? So that support is also coming in 1.5. Low-code application platforms or LPACs. This is actually one of the number one growth areas in enterprise IT today, especially for citizen development. Um, Neither SPDX or Cyclone today can actually represent low-code applications. We're changing that, which is one of the reasons why we're adding snippet support. And again, our snippet support is going to be very, very different than what you might have seen in SPDX. We are, like I said, we are supporting annotations. We're making our annotation support is a little bit different, though. It captures the same thing as SPDX. However, our annotations can be independently signed, so each one can have a digital signature applied to it. We're making enhancements to vulnerability disclosure reports, including the ability to hopefully get rid of PDFs when it comes to pen test results, because that's still a thing, unfortunately. And we're also adding a bunch of other things, including commercial licenses. We're adding a ton of fields just for commercial license support. While open source may rule the world, and license support for that is great, there is just as much of a demand on commercial license support for the SBOM use case. So we are absolutely adding like I don't know, I think it's like a dozen or so fields just to be able to support commercial licenses. 1.6, we're also planning cryptographic bill of materials. This is some work that IBM has done. They basically forked CycloneDX in a way that's backward compatible, and they made a cryptographic bill of material that describes all the different algorithms and all kinds of other things that is useful for identifying risk in a post-quantum world. So that might actually happen this year, but certainly by next year. We're also looking at attack surface mapping, so entry and exit points of the application, and a bunch of other things for 1.6. So there's a lot of really great stuff happening in CycloneDX that the community is actively working on. And with that, I'm going to hand it back to you.
Thanks, Steve. That was a wonderful overview. And at this point, kind of the last part of our presentation, we wanted to show folks quickly how you can use FOSSA to manage, generate and import CycloneDX SBOMs. And so at this point, Cortez, want to hand things over to you. For folks who have joined us more recently, Cortez is a senior product manager at FOSSA and is just going to walk folks through how to use our tool to do CycloneDX SBOMs. Please also note that I will post a link in the announcement section to a form, to a page, I should say. If you're interested in a more personalized demo or a more extended conversation, please feel free to reach to fill that out, and our team will reach out. And Cortez, take it away.
Absolutely. So I'm going to go ahead and share my screen now real quickly and walk through the demo. I do want to be very mindful of the fact that we have some awesome questions that have come in. So I'll try to do this in about 5 minutes and so we can save some time at the end to answer those real quickly. Here at FOSSA, we actually support two CycloneDX use cases. That's going to be importing existing CycloneDX reports and then generating CycloneDX reports from onboarded projects within FOSSA. So this is actually one of the sample reports that CycloneDX publishes. This is in the spec 1.2. We support ingestion for 1.2, 1.3, and 1.4 in both the JSON and XML formats there. So let's just go ahead and import this real quickly. All I've done is given this a quick little version bump here because I do want to demonstrate how you can actually upload new revisions to existing projects. I actually haven't changed anything about this software bill of materials, right? So picking it a little bit there, but wanted to be able to kind of demonstrate this for you. So taking a step back here, in FOSSA, anytime you want to onboard a new project, you can do so via the CLI, via quick import directly from your version control system, or now you can also upload a CycloneDX SBOM. In this case, I'm going to grab that 10.0.4 version of it, and you can see we can name our CycloneDX project, whatever we want to name it. Below, you'll notice it says creating a new project here. But once I change this name to match an already existing project, we're now uploading right to that existing, and it's just going to be a later revision. So we do that 10.4, 10.0.4. From that purposes, and just for the sake of completeness, we can do bulk import, right? So that way, if you do have a whole bunch of bombs that you need to import, you can do so effectively. Let me just go ahead and revert that. Alrighty. 10.0.4, and we will upload that file. Now, while that's uploading real quickly in the background, what I do want to show you is what the kind of end result is. And the power of being able to ingest a SBOM is you now can import third-party software vendors who are either making these publicly available or available to you as a customer, and have that full insight for both your first-party and third-party open source software supply chain. And so you can do absolutely everything that you can do with any other type of FOSSA project, right? And so I'm able to start going through issues that are now surfaced from these components that we've essentially downloaded, cracked open, looked for either license issues or in this case vulnerabilities, right? I can quickly filter down to these and then start really, be off to the races for addressing what I think are my highest risk issues. And then lastly, I'll just show you, one of these additional powers is that you can also, of course, convert this project into any of our other compliance formats. So if you want to do, an attribution report format and surface license vulnerabilities, you can. You can also annotate the vulnerabilities to your JSON report. So if you do not have those natively by default, you can then, ingest this SBOM report, annotate those vulnerabilities on there. And then we can kind of generate a new, CycloneDX, if you will, with those vulnerabilities annotated on there. And so just for the sake of completeness, to wrap out this demo or to round out this demo, we do have, in this case, I have this FileCore project, which is just a Netflix open source project for managing virtualized JSON objects. And so I just wanted to show how no matter what type of project that you onboard in a FOSSA, you can always generate that CycloneDX report. You can add the vulnerabilities in both JSON and XML. We can import in both of those formats as well, right? We can go ahead and generate and download that file. And in just a few short seconds, you'll have a brand new SBOM that you can go ahead and start reviewing. And so if we were to crack that open real quickly, just for the last kind of phase, over here, we'll see that our spec match is 1.4, right? We have some beautiful high-level information here. Some of the things that Steve was talking about earlier, right? If I can spell, there we go. We can quickly hop down to the dependency section and take a look at the relationships between your dependencies. So in this case, for my FileCore project, I have all of these direct dependencies kind of included. And then I can start seeing some of the transitive dependencies in this project as well, right? In this case, body parser uses these dependencies in it. And then, of course, since we did annotate those vulnerabilities, you can also see that information as well. So you now have this one-stop shop where in this particular case for this CVE, it has a score 7.5 of high. It affects these particular packages. And then we go ahead and give you some remediation guidance right there as well. So that way you know exactly which one that you need to upgrade and is this package affected or not. And so that is a super quick, fast, and dirty overview of our SBOM capabilities. And then just in full completeness, that project is still analyzing in the background, but you can see that it has been uploaded as a new revision. And then I can start scanning that and getting dependencies and so on and so forth. So this is the power of our third-party and first-party management. With that, I'll stop sharing here and pass it back over to Andy and Steve.
Thanks, Cortez. I really appreciate that. At this point, we will spend a few minutes with a Q&A. And Steve, I apologize because we've taken you over time, but are you able to stay on for maybe 5 more minutes?
I got about 5 minutes, yeah.
5 minutes. Okay, then let's go through these quickly. The first is an individual who missed most of the presentation but would love to watch the recording. The answer is yes, the recording will be available. It will be sent out to you after the event via email. So please keep an eye out for that. The second is a comment, I guess, that somebody had seen the demo screen blurred. Our apologies for that. I think the two things would be, one, when we do email you after the event, the on-demand link can sometimes provide a clearer recording for some folks, depending on connectivity. So try that. If it's still blurry, again, we would be happy to do a personalized demo and walk you through our capabilities. So please feel free to reach out and let us know if you'd like to go that route. Next question: can FOSSA ingest a CycloneDX SBOM and detect possible vulnerabilities? Cortez, I'll post this one to you.
Oh, sorry, I was over there getting off the mute. Absolutely. So we absolutely can ingest CycloneDX SBOMs. We will then surface vulnerabilities, and then of course you can then annotate those to your SBOM if you would like, and then regenerate that to exchange with whomever. So absolutely.
Perfect. Next question. This one would be for Steve. For FDA 510K submissions, are there any SBOM specific mandates that medical device manufacturers need to be aware of for new products and legacy devices, in parentheses, already on the field?
That's a great question. I don't know. I would encourage those folks to consult with the FDA. I know there is pre-market guidance and requirements for new devices coming to market. Whether those requirements apply to devices already in the field, I do not know.
All right. Next question. Why are we seeing multiple blue chip OEMs pushing back on Executive Order 14028, the NIST guidance from May of 2021?
Yeah, I think you have multiple. In my opinion, obviously, there's not a lot of data, public data, but in my opinion, there's a lot of pushback from some of the larger organizations because the amount of customer support necessary to be transparent is going to overwhelm a lot of customer support sites. So while we have SBOM and SPDX and Cyclone are here to be able to do that, what we don't really have is a lot of consumption tools. We don't have a lot of standards for sharing SBOMs, nor do we have a way to mute all the noise that's going to arise when analyzing SBOMs. I'll give you a couple examples. If you analyze an SBOM, if you get something from a vendor, and regardless of what source of vulnerability intelligence you're going to use, it's going to pop up with a number of vulnerabilities, and the first thing you're going to do is call that vendor times however many customers they have. So it's going to be kind of overwhelming, which is why this concept of VEX, or vulnerability exploitability exchange, is being so prominently targeted for vendors. It's a way for them to say, no, I'm not affected by this. Unfortunately, VEX also has issues. It's not really overly beneficial for the defender because it doesn't go into a lot of the data that they need from a defender's perspective. But yeah, I think there's just a lot of, again, for the sharing, as a software consumer, I would have to, for every vendor that I do business with, I'd have to like send out 10,000 emails or log into 10,000 support portals or all these other things. The infrastructure to be able to share SBOM en masse just isn't really there. So while SBOM is great and it's already here, a lot of the supporting infrastructure around it just isn't quite in place yet. So that's one of the reasons why I think a lot of folks are pushing back a little bit.
Got it. And so I think we have time for probably two more at this point. If we are not able to get to your question, our apologies. I would suggest in our follow-up email after this webinar, there will be contact information for Steve as well as FOSSA. So you can use one of those to reach out, and we will do our best to get back to you. I think for the second to last question would be for Cortez. For the FOSSA CycloneDX integration, is it possible to delete a previously uploaded version?
Yeah, that's a great question. So you can absolutely delete an entire project. If you mean like just deleting that individual revision, like I just showed you, we do have that available via API. It's just not publicly facing at the moment. So I will definitely take that as the feedback to make that publicly facing. I think that's a great improvement.
Last question. Will the SBOM mandate add pressure to manufacturers to avoid software packages/libraries that are no longer under community support or in frozen state of updates/releases, i.e. too old? If so, is it realistic to achieve in view of reusable code popularity?
So yeah, this goes into a lot of open source policies. I know a lot of high assurance environments, they typically have open source policies of between 3 and 5 years, and anything older than that, they just will not allow. Do most organizations have these policies? No, but SBOM will provide the necessary transparency, which I think is a good thing. Now, there's also the nuance of, maybe I am using an old, obsolete thing, but maybe my organization is continuing to maintain it internally. And that's a perfectly valid use case. And if you can describe that all those contributions in the form of pedigree with your bill of material, I think it's kind of the one of the exception use cases. But yes, I hope it shines a light on a lot of these older components because this is a real problem.
All right. Well, that is all the time we have for today's presentation. Again, our apologies if we submitted a question that we were not able to answer, but do feel free to use the links in the email that you will be receiving later today or tomorrow. And so with that, we will wrap. Steve, thank you so much. This was a wonderful presentation. Extremely insightful and hopefully valuable for everyone who is here. Cortez from FOSSA, thank you so much for taking the time as well and for conducting that brief demo. And of course, last but not least, thank you to everyone for being here and taking time out of your days. So we will go ahead and close now. Thanks again, and hope you have a great rest of your Wednesday.
Take care, everyone.
Cheers.